Friday. You'll see this cohort question again. So yesterday, they introduced the energy equation. Monday, we introduced the speed of light equation. Today, we're combining the two. Now, I will give you these equations on the quiz. I will also give you the constants. Speed of light, Planck's constant. What's the significance of the speed of light and Planck's constant? They're both in what? Freddie? They're both in Drew. Ben? They're both in Aiden? They're both in seconds. You notice up here, the unit of time in science is seconds. You see here, this is in seconds, this is in seconds. So it travels this distance 3 times 10 to the 8th meters in 1 second. We care about seconds. It's just how life is. How many seconds you do that in? Well, 1, faster than Usain Bolt. Thank you very much. That's like, he's like a turtle compared to this. It's light. 3 times 10 to the 8th meters in a second. Blazing. All right, up here we got Planck's constant, 6.63 times 10 to the negative 34 joules. That's energy per second being transported from one location to the next. It's a lot to say. Transported in a second. So constants are typically associated with seconds. Why seconds? It's the smallest unit that humans can comprehend, typically in time. You got seconds, minutes, hours, days, right? That's a good question. You're going to have to use some dimensional analysis. So you're going to take 525 nm times 1 meter is 1 times 10 to the 9th nanometers. And you get an answer, and then that goes into your formula.
Okay.
So you can see I'm going to give you that too on the test quiz, that is. The formula will be given for you, and the correct 5.25 times 10 to the negative 7. 0.79 times 10 to the negative 9 joules. That would be the energy associated with this particular reaction. Now today we're going to spend some time on your digital backpack Nobel Prize winner. I'm going to show you where to turn that in. You will see the assignment expository for the Nobel Prize in chemistry. You're going to pick a Nobel Prize winner, and you're going to do an expository writing assignment on how it relates to your life, what the prize did, as far as how it benefited civilization, and then how it affected your life. Also, you have to have what in there? Aiden? Lily?
You have to Photoshop a picture and talk about their struggles.
Yes, the struggles is the most important part of it, because the more failure you have in life, the more likely you will be successful. People who are sheltered don't tend to be very successful. And also people that are given a lot of stuff. Like in high school, I always remember the kids that had like the brand new cars. I always struggled in life. Because, I mean, things were always given to them. And when they got into life and they found out that's not typically how it works, that is capitalism. Communism, they give you stuff. And if you look at Russia's population, it's a little lower than ours. They have about 100 million, whereas we have about 300 million. China's a little bit different. You can use the online Pixlr app. So it's a free app that you can use online. You can do it pretty quickly. I'm not asking for like excellence. I'm just asking for first exposure to it, being able to blend two pictures. a paper copy. You're going to upload your document to the digital backpack classwork. It's underneath classwork on the Google Classroom. And from there, if I think your project is pretty good, I'll try to post it on KentuckyScience.com as a link. I always like to showcase student work. And your pictures, too, are always cool to showcase as well. Your creativity, artwork, you'd be surprised. It draws a lot of attention. So keep that in mind.
Are you going to explain that?
No, I will. Now, if you're still struggling with this, if you're like, Mrs. Stock, man, this is the toughest problem I've ever seen in my entire life. I would never be able to come up to this board and explain it to you. Struggling. If you look on your sheet, the answer for it is given in the example. So, I mean, here I am, fourth period. I've only had like one person get up on the board and do it, only one person. And it's just, I just wrote the example out from the worksheet. Just saying, I'm giving some glory to Florencia. I have to see the name. Your name is such a beautiful name. I have to see it when I say it. As a recap, we're going to find the horizontal and vertical components of the 124-meter displacement of a superhero, Joey Wisdom, who flies from the top of a tall building along the path shown. So the book has a diagram showing the superhero flying in this direction, 124 meters, and they want to find A of Y and A of X. I drew over here the triangle showing the angle 39 degrees, and that they're looking for the A of X length and the A of Y length. So students were able to take the formula for the A of the Y, the cosine, the C, hypotenuse length, times the sine of the angle to find the distance for the A of the Y, which is right here, the A of the Y. Also, students went over that they need to know this information here associated with the tangent of the angle is A over B, cosine would be B over C, and the sine would be A over C. So we have that written right here. Lastly, we were going to solve for A of the X, and the A of the X is right here where we take the 124 and the cosine 39. So that's associated with this degree here. So we have to make sure we have the degree in the right area associated with the A and the B. If the degree is up here, it's flipped. That is, if the degree is there, the A is here and the B is here. So understanding the relationship between the sine, the cosine, and the tangent, and your triangle is very important to solve for these particular problems, as we discussed today in the book. So this problem will be the math problem that they see on their quiz on Friday. I forgot to record this in class, so I'm just making a note of it for any student that may be absent. If they see this and they don't understand, they can come to me for further explanation. Okay, very good. Who wants to continue?
Where are we? Paragraph?
Yes. Shh.
Alright. Pennies with different chemical compositions have different masses. In this activity, a mixture of pre- and post-1982 pennies will represent a natural occurring mixture of two isotopes of the imaging element chromium. The pennies will allow you to learn one way that scientists can determine the relative amount of different isotopes present in a sample of elements. You will be given a sealed container that holds a mixture of 10 pre- and post-1982 pennies. Your container might hold a particular combination of the two isotopes. Your task is to determine the isotopic composition of the element chromium without opening the container. You are reading your stuff.
I keep going.
To illustrate how this is done, we can consider a mixture of two isotopes of
You only need to measure one. You can multiply it times 10. Look at an average atomic mass problem. You know you're going to be addressing what? mass. So I'm going to put my mass on my scratch sheet of paper. Does everybody see those are the masses? Then you're going to multiply times the percent. So you can't multiply times the percent, so I'm going to divide by 100. So I get times 0.48 times 0.43 times 0.09. Does everybody see how I got those numbers? I just divided by 100, the percents. Then you're going to do your math here. Values together, adding the values. We get 30.13 AMU. So the atomic mass unit would be 30.13 AMU. So here we have the total mass of the container minus the container. We wrote the container mass on the container. So if you decide to do this, do that. So now we have 27.7 equals X times, what's the mass of a pre-penny? And then what's the mass of the post penny? So if we multiply these two, we get 24.9 minus 2.49x plus 3.07x equals 27.7 grams. We'll just drop the unit here because it'll get confusing if we don't. So now we're going to solve for x. We'll stop there.
And I was like, he's not even playing. He's not playing. He's not like this, bro. He said, that's what I did for my class.
Container mass minus the container. Penny mass goes here. This should be around 25 or 26. And then you're going to find the mass of a pre-penny, mass of a post-penny, solve for x. Math they teach you can't multiply times a percent. Then just going to take 31 times 0.43. And then 32 times 0.09. So once Samara adds all of them together, she will get the average atomic mass unit, or the AMU, atomic mass unit. So you would just put AMU, 30.13 AMU. Excellent. So it's not that difficult. There'll be more than one on a quiz like this because it's so simple.